Hello guys. Today this video is not about math textbook, but it's definitely about math. Alright, I want to talk to you about some video I come across during my leisure YouTubing times. I come across this particular video presented to us by the so-called the human calculator. His name is Scott Flansburgh. You can Google him. You can YouTube. On YouTube you can search for his video. I think he's amazing. He's literally the human calculator. One of his talk, he talks about the design of the Arabic number, and I thought, wow, I was never told about that, and that is really like that moment of me. I connected with the number a bit more, and I think I really need to make this particular videos to show you guys what Scott has told what Scott has told me through that videos, and I really wanted to share with you guys. And by all means, all the credit goes to Scott Flansburgh, the human calculator. And so please go check out his website, and I think he's have something very cool going on with him, which is about his own calendar. He's produced his own calendar. He's an amazing person. But let's get into the today's main topic, the intelligent design of the Arabic number, the Arabic numbers. All right, you ready? Like normally when we go through this, we need to, normally when we go through something so exciting, we need some BGMs and we need some background music. So allow me to turn on some thinking background music for you guys. Alright, let's go. So as we know, there is 10 Arabic numbers, alright? And I don't mean 1 to 10. I actually mean from 0, 1, 2, 3, 4, 5, 6, 7, 8, and 9. And any number, alright, can be formed by a combination of these 10 number, right? A 10 is just 1 and a 0. Alright, and 20 is just 2 and a 0. 345 is just 3, 4, and 5. So, you have to realize back in the day with this different number system or different number symbols around in different countries in different continents, and one of the major one was the Roman, the Roman number system, which is 1 that is equal to 1 that is equal to 5. V is equal to 5, and what's equal to 10? X is equal to 10, and L is equal to 50, C is equal to 100, and D is equal to 500, and so on and so on and so on, right? So we know that there are different number system existed before. So why did we at the end well, we didn't end up using this. We still use some of the on some of the watches we still see Roman number system on it. But what's so special about the Arabic number is, why do they choose this? Why do they choose this symbol as 0, a circle, and then a 1 as 1 and 2 as 2, right? And Scott, the human calculator, proposed this particular theory, which I think is interesting, extremely interesting. The reason why they use symbol like this is to tell you how many angle is within a number. So if it is 1 angle, then that symbol represents 1. If there's 2 angle, then the symbol represents 2. All right, let's go into it. I'll use a different pen. All right, I'll use black. All right, let's go with 0. All right, just a circle. How many angle can you find in a circle? No, don't tell me 360. I mean, how many corner? Literally, how many angles is there? All right, there's none. It's a circle. All right, there's no corners. All right, so there's therefore 0 angle or 0 corner. Right? So it is representing 0, nothing. All right, let's look at the 1. All right, the 1 is written like this. And you can immediately see that there's an angle there, there's a corner there, right? Hence, 1 angle or 1 corner, right? All right, let's go into 2. 2 can be used to be written like that, like a Z, like a Z, like a Z, Dragon Ball Z, like that. And there's immediately 2 angles. 1 here, 2 here, right? So you represent 2, the number 2. So it's 2 angles. Or 2 corners if you want it. Alright, let's go to 3. And 3 looks like this before. It likes that. Alright. And now you can see there's 3 angles. 1 is here, 1 is here, and 1 is here. Yeah, 3. 3 angles. 3 corners. Right? Alright, you see it's slowly getting a hang of it? Alright, let's go to 4. 4 used to be written like this. Very good. Used to be written like that. 4. And well, obviously we've got a triangle. We've got 1, 2, 3, 4 angles. Yeah? So represents 4. Alright, let's go to 5. 5 is written like this. Right? How many angles there? Well, let's count. 1, 2, 3, 4, 5. There's 5 angles or 5 corners, as you want to call it. Somehow I think angle is more accurate. You know, there's more corner than 5, but you know, just how different people see it. All right, 6. Simple. But this is what 6 look like. Right, and let's count. 1, 2, 3, 4, 5, 6. 6 angles. And 6 corners. Or whatever. I don't think the corner makes sense anymore because you can see different corners. But you get what I mean. 6 angles. Alright, 7 now. Most of the people, when they get to 7, they say, okay, how do you make 7 angles out of that? Alright, out of this. How do you make 7 angles out of that? But mind you, that's what I thought as well. But something I realized when I study in Australia, especially Queensland, I see people write 7 quite differently. They write like that. I don't know, because I was never been taught like why would you write 7 like that? I thought 7 is just 7 is all been just like that. But no, people over here, they write 7 like this. Or in most of the Western world, they write 7 like this. And there's another genius who thought about, okay, why don't we put another 7 here? We'll put another line here, right? It still looks like a 7. And then you see 1 angle, 2 angle, 3 angle, 4 angle, 5 angle, 6 angle, and 7 angles. Amazing. 7 angles. Yeah? Alright, next one. 8. Now 8 used to be represented like an hourglass. Yeah? And there's 8 angles in there, believe it or not. 1, 2, 3, 4, 5, 6, 7, 8. 8 angles. Right? And last but not least, we get down to the 9, which is the fun bit. Right, so this is what 9 is. This is the 9. Alright, let's count. 1, 2, 3, 4, 5, 6, 7, 8, 9. Oh my god, there's 9 angles there. Right? And I thought, wow, isn't that amazing? Why? If we teach that to the younger people, to the younger kids, like year 3, year 4, wouldn't they love number? Wouldn't they find that more? Wouldn't they develop more connection with numbers, numerals, or just in terms of numbers? Isn't that wonderful? And that's why I want to share with you, within this 10 minutes, to share with you this is possible. This is how you can see it, and this is how you can teach other people about younger people about numbers. Isn't that amazing? Alright, that's what I got for today, and if I come up with any other interesting thing, I'll let you guys know. Alright, see ya.